In this lesson, you will write and graph direct variation equations and solve problems using direct variation. So we better know what that is. Direct variation is an equation in the form y equals kx, where k is not 0. So this is going to be a linear equation that has just a y equals and then a constant kx. The constant of variation is known as k. This is called the constant of variation, and it is in this form, y equals kx. This is also called the constant of proportionality. And I'm going to tell you it's also called one more thing. It's also called slope. And you're going to see that in just a moment. So the constant of variation is here. It's k. So I want you to name the constant of variation in each line. Well, look right here. This is y equals negative 4x. So this fits that formula. Y equals kx. So we could say that k is negative 4. Now let's find the slope. Well, we're going to use slope formula from yesterday. So m is equal to y2 minus y1 over x2 minus x1. So when I simplify, I get negative 4 over positive 1, which m is equal to negative 4. Look at that. K and m, they're the same. They're both negative 4. The constant of proportionality is slope. And slope is the constant of proportionality. So yeah, if you didn't want to do all this work, you wouldn't have to. But I'll keep doing it just so we can have good practice. Here is another line. And the formula is y equals 1/2 x. So k is equal to 1/2. Now some of you are already writing m equals 1/2, and you're going to be right. But let's go ahead and use slope formula just to check it. So I'm going to do y2 minus y1 over x2 minus x1. And I get negative 3 over negative 6, which simplifies to 1/2, because it's positive 3/6, and that would be 1/2. So m is equal to 1/2. So m and k are the same thing. The reason we don't use m is because this is a very special formula, y equals kx. I want to show you why. This goes through origin, so does this. Anytime you have this type of equation, you know it goes through origin. You know origin is one of the coordinates. So let's graph one. We're going to graph y equals negative 6x, and yes, you already know it's going to go through origin. So our k is negative 6, so that means our slope is negative 6. Remember what slope is? It's rise over run. So we're going to rise negative 6, and we're going to run 1. Well, that means we're really going to fall 6, right? So 1, 2, 3, 4, 5, 6, run 1. And now I can connect with my ruler and draw my line, okay? I know that's a horrible line, but I don't have a ruler. Y equals 2/3 x. I go ahead and put origin here. My slope is 2/3 because k and m are the same thing. And so this is rise over run. So I'm going to rise 2, run 3. So rise 2, run 3. And I'm going to connect it and draw my line. So you can plot using slope. As long as you're calling slope rise over run, you can plot and draw a graph using just slope. Now, suppose y varies directly as x, and y is 72 when x is 8. So this is my formula, y equals kx, and y is 72, and x is 8. Now this is multiplication, this is not a power, okay? This is k times 8 or 8k. So if you want to rewrite it to this, that's okay, that's fine. And I want to solve for k. Well, divide by 8, and I get 9 is equal to k. So k is equal to 9. Now I'm going to use this to write into this formula, because it said to write a direct variation equation. So I have to have y equals, here's k, x. So this is a direct variation equation for when y is 72 and x is 8. Now I'm going to use this formula to find x when y is 63. So I just plug in here. 63 is equal to 9 times x, divide by 9, and you get 7 is equal to x. So I would say x equals 7. When you do this on your worksheet, you are going to have to pay attention to if you're looking for x's or y's, because it will change. Sometimes you find x, sometimes you find y. Here's a real-world problem. The distance a jet travels varies directly as the number of hours it flies, and so it traveled 3,420 miles in 6 hours. So let's write a direct variation equation for our distance and our time, d and t. So if you look here, distance is y, and our time hours is x. So I'm going to write this in this form. y equals kx, but it's actually going to be, in this case, it's actually going to be d equals something t, okay? So what do I know about this equation? Well, I know we have 3,420 miles is equal to 6 times k, because I know my time. Divide by 6, and we get 570 is equal to k. So I will now plug that into this equation, and I get d equals 570 t. And what that means is, for every hour it travels, we're going to go 570 miles. So you can graph this. I have 0, 0, and then I climb 570 in 1 hour, and then I would have 570 doubled in 2 hours, times 3 in 3 hours, and so on and so forth, and I could draw then an array for that information. So if we could estimate how long it would take us to fly 6,500 miles, I would just plug in here. 6,500 is equal to 570 t, divide by 570. Type that in on my calculator here, and I get about 11.4. So in the real world, you would say a little bit more than 11 hours. Okay? And so you'll try a real world problem on your own.